Hello and welcome back to my channel. So in the last video we were talking about linear differential equations. In this video I'm going to discuss about differential equations of a second order or the differential equations that look something like this. We have dy by dx square. So we are differentiating 2 times, that's why we get the order of 2. So then we have p dy by dx plus qy equals 0. So when we see something like this and differential equations which in one term we are differentiating twice, so the order is 2, therefore this becomes differential equations of second order. Also where p and q are constants. So here q is also a constant. So how do we solve these type of equations? Well, we know that dy by dx, so d by dx in itself can be written as d. So we can rewrite the equation as d square plus pd plus q, and we have taken y as common. So here we have got this, we have rewritten in this form. So now we can see that this part looks similar to a quadratic equation. A quadratic equation looks something like this. A quadratic equation which you might have solved in earlier classes. Quadratic equation looks something like this: ax square plus bx plus c. So here we can see that they look similar, and therefore we assume it to be a quadratic equation. So here we assume that d becomes a variable, right? So we solve for d, we find the value of d in this quadratic equation. So simply we can write d again as a variable m. Let's put d equals m. So here I can rewrite the equation as m square plus pm plus q. So here only this part I have rewritten. This is the quadratic equation, and now when I solve this quadratic equation, now if I get m, the root of this quadratic equation, I will get 2 roots. So if they are real numbers and distinct, so they are different from each other, m1 is not equal to m2. So when m1 is not equal to m2 and m1 and m2 both are real, then the general solution of the original differential equation comes out to be y equals c1e to the power m1x plus c2e to the power m2x. So this is the general solution of the original differential equation. Similarly, when m, we are not always going to get m as real and distinct. Sometimes we'll get m as complex numbers. So if I'm getting m in the form of a complex number, let's say alpha plus minus I beta, right? This is the complex part. So the general solution of the differential equation will be y equals c1e to the power alpha plus I beta x plus c2e to the power alpha minus I beta x. And then when we have m1 equals m2, so both are real and equal, then the general solution will look something like this. We have c1 plus c2x e to the power m1x. So now we have understood all this. Let's solve an example. So let's find So we need to solve the differential equation given as d square y by dx square plus dy by dx minus 2y equals 0. So we can rewrite this in terms of d, and it will come out to be d square y plus dy minus 2y equals 0. Again, when I'm taking y as common and assuming d to be a variable, then I can rewrite d as m square plus m, right? I'm getting a different quadratic equation here. Solving this quadratic equation, I'm getting m as plus 1 and minus 2. So here they are real numbers and distinct. So therefore the general solution of this differential equation will be c1ex plus c2e minus 2x. So here we know that c1 and c2 are arbitrary constants, so they are different constants. That's why this is called the general solution. So we don't know the value of those constants yet. So we have understood a general solution, the differential equation of second order. So in the next video I'm going to talk about non-homogeneous differential equations. I hope you like this video and thank you for watching.